Okay, let's look at the scalar product. It's another simple little process with vectors, but we've had a lot of those, so you want to keep making these and adding them to your notes. Okay, so scalar or dot product. You'll see why it's called the dot product, because that's how we represent it, right? Nice big old fat dot there. And to work out this scalar product, it's a simple matter of just taking A1 and we times it by B1 plus A2 times B2. So what happens when we do that is we in fact get a scalar. We don't get a vector, we get a scalar. So as an example, let's take A to be 1 and 4, and we'll take B to be -2 and 3. So to work out our dot product, it is simply 1 times -2 plus 4 times 3. So -2 plus 12, 10. Now that means absolutely nothing. Okay? The only time that this is relevant is if we have the dot product or the scalar product. If that equals 0, then this means that A is perpendicular to B, right? Otherwise, it's just you'll be doing all these exercises that's asking you, oh yes, find the scalar product. Well, you just get a scalar. Okay, and remember, we can also use your calculator to work this out if you want to, but again, it's so simple to do it by hand, but you know, they're costly, these calculators, so let's use them. We'll go to option, okay, go to your matrix again, and then F6, F6, and you can see over here we've got dot product. So you'd go F2, and again exit, exit, so we get maths back again, pop in maths, and F1 for vector, we're going to put 2, 1. We put our first vector in, which was, what was it again? I've forgotten what it was. 1, 4. So you pop in 1 and then 4. You can see already this is more work, and then push the 2, 1 again. This is more work than just doing it by hand. -2, 3. -2, 3. Close your bracket, and yay, we got 10. Now where we actually use our scalar product is when we want to find the angle between two vectors. Okay, so if I would like to find the angle between the vectors A and B, okay, so we've got A here and we've got B there. Okay, if I want to determine this angle, I use this formula. So this goes onto your help sheet. So cos theta equals the dot product of A and B, and we're going to divide it by the length of A times the length of B. So to find the angle, we'll just shift cos of all of that. Now, when my dot product, when it's positive, so when it's greater than 0, that means that our angle is acute, so it's less than 90 degrees. If my angle is obtuse, so it's greater than 90 but less than 180, you will find that your dot product in this case will be less than 0. It's just something to keep an eye out. And the other thing is that if a question could say, I've got 3 points, let's say the point A, the point B, and the point C. So let's take A here, C, and B. It's really important. You can't just go, oh yeah, I'll work out the vector CA and then AB. You've got to have it going out in the proper direction here, right? So it has to be AC dotted with AB, not CA or BA, A out, so A outwards, and then outwards there, so AC dotted with AB. And really, you can't go too wrong with that. And again, on your calculator, we can do a little bit of a shifty maneuver here because I've already got that written. So I'm going to delete and exit, exit. So we're going to go, oops, delete again. and I'm going to go option, the F2, so matrices, F6, more, and then we can see here angle. Make sure your calculator is in degrees. Okay, and 47.7, now that's an acute angle because our dot product that we worked out before was 10, that's positive, so we can say the angle is 47.7. So that's pretty much it. If you can sort of work your way through the exercises for those, I think this one's J. Probably don't have time to do every single question, but just so you get the maneuver of using technology and your formula. All right, good stuff.